Okay, we're going to continue with solving radical equations. And the next one we're going to work on is the cube root of x minus 5 plus 2 equals 1. And we said in the beginning that your first step is to get the radical by itself on one side of the equal sign. So I'm going to subtract 2 from both sides to get that radical alone. So that gives me a negative 1. Now this is okay, because remember we talked about square roots, you can never have a negative as a result, but cube roots you certainly can. So we're okay to keep going here. So once we got the radical alone, we are supposed to raise these to the exponent that matches our index. So here we're going to do the cube root, and here we're going to do the cube root, like that. Or sorry, not cube root, we're going to cube them. And when these match like this, what your resulting answer when you have the radical is x minus 5, right there. Okay. And then negative 1 to the third power gives us negative 1. And then we're going to get x alone. So we're going to add 5 to both sides of the equation. And that gives us x is 4. Now, one of the steps that we talked about was always checking your answer, because if 4 doesn't work, we would say there's no solution. So let's test our answer. The cube root of 4 minus 5 plus 2, does that really equal 1? And so 4 minus 5 is negative 1, so the cube root of negative 1 plus 2, does that equal 1? Well, cube root of negative 1 is negative 1. Negative 1 plus 2, does that equal 1? Sure enough, that's true. So we would definitely say that our x is positive 4. Great news. All right, let's try another one over here. We have the cube root x plus 4 plus 5 equals 3. First step, get the radical alone. Doesn't matter really which side of the equal sign the radical's on. If it was on the other side, we'd still just get it alone. No problem. Okay, there we go. Now our index is a 3. So we're going to go ahead and cube both sides of the equal sign. And we have x plus 4 on this side. And then negative 2 to the third power. You can put that in your calculator if you want, but we have a negative 8. And then solve for x. So we'll subtract 4 from both sides to get x alone. All right. So we're saying our answer is negative 12. So let's check it. Let's find out if that works for this problem. We have the cube root of negative 12 plus 4 plus 5 should equal 3. Let's see, negative 12 plus 4 is negative 8. So the cube root of negative 8 plus 5 equals 3. So this gives us negative 2 plus 5 equals 3. Negative 2 and 5 is 3. Sure enough, it's true. Thankfully, that one was true. In fact, they get true so often that it kind of fools you into thinking you don't have to check your answers. Don't fall for that trick. It does turn out badly sometimes. So you want to make sure you check your answers every time. Okay, so what if we have two sets of radicals in the problem? Well, we have 4y minus 2, and we have 3y plus 9. you know, it's okay. We just do it the way we were doing it on the others. We have the one of the radicals by itself, doesn't matter which one, and if we had other ingredients, we would just make sure one of the sets was by itself. And now, since the index is 2, we'll go ahead and square both sides. And so we end up with 4y minus 2 is equal to 3y plus 9. Not bad. And then solve for y. Not too hard. Let's subtract 3y from both sides to just have 1y in the problem. And then add 2 to both sides. And we find out that we're hoping y is 11. And again, check your answer. Is it true that the square root of 4 times 11 minus 2 is the same as the square root of 3 times 11 plus 9? Well, that's 44 minus 2, which is square root of 42 on this side. This is 33 plus 9, square root of 42. I'm calling that true. There you go. Y is 11. All right, we'll try another one of those. 2y minus 7 equals square root of 8 minus y. We already have a radical alone. Square both sides, and you get 2y minus 7, 8 minus y. Get y alone, solve for y. So I'm going to add 1y to both sides. And then I'm going to add 7 to both sides. And then divide by 3. Y equals 5. Let's see if that's true. Is it true that the square root of 2 times 5 minus 7 is the same as the square root of 8 minus 5? Well, that one's a little bit easy. Square root of 3 on that side. 2 times 5 is 10 minus 7. Sure enough, square root of 3 makes it true. Not too bad so far. Looks a lot scarier than what it really is. Okay, now I'll really make it look scary here for a minute. It's not as bad as it's going to look, but I'll take you through it. Let's see here. We have a plus 1 on one side, and we have a minus 2 plus 1 on the other side. Looks a little more complicated because we have that addition of the 1 over here, not just the radicals on both sides. But really, we're still going to do the same thing. We do have a radical by itself right now, so that's good news. Now we're going to square both sides of the problem. And it is going to take a little bit more work here. When you square this side, you do get a plus 1. But on the other side, we have to FOIL this. So we're really going to have square root of a minus 2 plus 1 times the square root of a minus 2 plus 1. And remember I like to write FOIL. We're going to do first outer, inner, and last. So when we multiply the first in each set, it's the square root of a minus 2 times the square root of a minus 2. Well, the same thing times itself ends up with just what was in the radical. It's just a minus 2. And then the outer edges, so it's this root times 1. So it just gives us that root. Anything times 1 is itself, so we'll have a minus 2. The innermost, it's this 1 times that set, and so once again we have just that set of a minus 2 inside the radical. And then the last in each set, we have a positive 1 times a positive 1. All right, now just like with normal problems with FOIL, very often the O and the I are like terms, and sure enough they are. Remember, these are 1s out here, sitting in front of those. So we really have, this part comes together and we have a 2 times a minus 2 for that part. Then some more like terms. We have a negative 2 here and a positive 1 here. And so we'll call that a negative 1. And then we have this a. So we can say plus a. It's positive there. We can write it in any order. This set could have come first, and then we could have said minus 1 plus a. Really doesn't matter. All right, so this side of the problem gave us a whole lot of work. And that's all equal to a plus 1. So we're not there yet. We don't know what a is, but we were able to get rid of the radical on the left and kind of do the work coming down here on the right. But notice we still have a radical. We have one on the right-hand side. So we're going to repeat the steps. We're going to go through and we want to get this radical by itself. So I'm going to add 1 to get rid of this 1. I'm going to add it on both sides. And my radical is not alone yet, so I'm going to subtract a here and subtract a here, but these are going to all cancel out. So I'm so far left with 2 is equal to 2 times the square root of a minus 2. So now what I want to do is get rid of the number that's outside of the radical, which is this 2, and it's being multiplied right now. Always when you want to get rid of something, you do the opposite of whatever's happening. So that means I'm going to divide by 2 here and divide by 2 here. 1, and then on this side we have our a minus 2. Phew, okay, now guess what we got to do again? Remember up here we took the index and used it as a exponent? Well, we need to do that here again. So because this has an exponent of 2, or excuse me, an index of 2, we have to square this to get rid of the radical. And then we have to do that on both sides of the equal sign. Alrighty, so 1 is equal to a minus 2. And we finally get to solve for a now. We're going to get a alone by adding 2 to both sides. And so we find out that 3 is equal to a. Yay, that was a lot of work. Whole lot of work there. A is 3. Now you want to make sure you double check it. Make sure it wasn't a no solution problem. If you come up here, 3 plus 1 is 4, so the square root of 4 is 2. This side equaled 2. Let's try this one. 3 minus 2 is 1. Square root of 1 is 1. So 1 plus 1 is 2. So these matched on both sides, so I can confidently say that a is 3. We're almost done with 10.6. Just a little bit more to go. That's a tough one. Okay, let's try this one.